I would like to invite first Geremy from Australia.
Thank you very much.
Do you want to listen?
Yes. I thought just quickly, just to give you an idea of what our responsibilities are in Western Australia. Most of our shipwrecks date from a period after from the beginning of the 17th century. They're mostly in the 19th and 20th century. Of course, we have the first evidence of sea voyaging by the ancient people some 60,000 years ago. But most of the work that I'm involved in and my department are involved in is European shipwrecks and the management of those shipwrecks. You have to understand the scale of what our responsibility is. Western Australia is probably about the same area as Europe, and it ranges from the tropics in 15 degrees south to 35 degrees south. And just to remind you that from Perth to Sydney, which is on the other side of Australia, is further than London to Moscow. So we have a big area to cover, and we have responsibility under several acts to manage and look after these wrecks. We also have a program of looking for wrecks. What I want to talk about very briefly today is a project that we've been involved in relating to mostly a magnetometer operation, but also a little bit of acoustic work too. Off Fremantle, where I come from the West Australian Museum, this is a very old map, but there was a dumping ground where vessels that were out of date or no longer used were taken out and dumped. Here is Fremantle, and this is what we call the Deepwater Graveyard. We had a project some years ago with a company to look at the possibility of whether you can locate wrecks in deep water using a magnetometer, an aerial magnetometer. Our problem was that in using a marine magnetometer is very time-consuming and it's weather-dependent. The magnetometer survey in two areas, one of which was what is the Deepwater Graveyard here. This ranges from 80 metres to 100 metres, and this area here where a modern warship was scuttled in 200 metres of water. Both of these surveys took probably about an hour to survey using 50 metre lanes, and in the graveyard we had about 10 wreck sites. What we were interested what we found interesting was when we started to analyse the data, the magnetic data, that we had this problematic system that the run lines, which you can see here, have what we now know is to be swell noise. Swell noise is the movement of seawater. It's a swell here is about 4 metres, so the seawater is moving up and down, influencing the Earth's magnetic field. And currently we're on a project trying to find a way of removing this swell noise because we have data from the survey work, the radar data that tells you the height of the aircraft above the water, and to see if we can extract the information and get even more archaeological, a better picture of what the magnetics of the cultural heritage is, or the underwater heritage. This is actually the 200 metre deep wreck site. It was a warship that was scuttled in the 1990s. This is actually a multi-beam image of the vessel in 200 metres of water. 200 metres of water, it's quite interesting. 2 years ago, technical divers dived on the site. They spent, I think, 7 minutes descending, 7 minutes on the wreck site, and 7 hours decompressing. But it does mean that it's now within the access of technical diving to get to these sites. There are, of course, other ways to do it with submersibles and ROVs. But the other thing that we found with this survey is that when we started to analyse the data, we came across this very large target here. We suspect it was a submarine sunk at the end of the Second World War in the graveyard. And we were very optimistic that we found the submarine. When we went back 2 days later, that target wasn't there. And we're very close to a naval base. We suspect this was actually a Collins-class submarine, or maybe a submarine from some other country, that was passing through the area. But this target here, next slide, which you can see in detail, unfortunately, right at the edge of the survey area, next slide. But this is a multi-beam survey that was done, and I'll tell you a little bit more about that, but that target there corresponds to the magnetic target. So we think that could be a submarine, it might not be. This is the multi-beam survey. This was a survey carried out by the government to look at what they call marine futures. The idea being getting a typology of the seabed to see what resources come out. What we found this information was available, and we were able to gain access to it. So it gives us a very good cross-section of being able to check against our own work. And this is just a picture of one of the wrecks. This is a whaling ship that was sunk in the 50s. You can see that this is in about 95 metres of water, and this photograph was taken from a two-person submarine. You can see that our coordinates, the magnetic target and the GPS information enables us to get exactly onto the site. That was deep water. The other thing that we were interested in was shallow water. We have a Portuguese ship that was wrecked in the north of West Australia in the beginning of the 19th century. And for many years, about 4 or 5 years, we've been carrying out visual searches and marine searches looking for the wreck. We spent months looking for this site. But what we were able to do with the magnetic survey is in the same way. This is the area of the magnetic survey, and we were able to find, if you look on the site here, these sites, the Perth, the Benan, the Rapid and the Stefano, were all found before the survey. And this area here are 2 targets here, which you can see on this aerial photograph. That's one target, that's the next target. Oh, one more. No, sorry, one more on. Yeah. The magnetics in shallow water is very interesting. Those two targets that we found, I have to go back now for it. These are the tracks of our visual survey in the 1990s and 2000. These are the 2 sites that one is Corrigasia and the other one is an Unknown site. Both sites having got the coordinates from the aerial survey work, we were able to find within 20 minutes. The sites consist, in one case, of 2 anchors, and in the other case, with the Corrigasia, 1 small anchor and 2 iron cannons in probably less than 10 metres of water. But the ability to find things that small in shallow waters, from our perspective, is a very effective way of operating. and particularly when you can get the multi-beam survey, or in some cases we're now looking at LiDAR to try and back the aerial magnetic work up with the sorry, can you go back one? I've got my slides out of order, one backwards. Yeah. What is interesting though is that in certain cases the background noise, the geological noise that occurs here, this is actually probably an ancient watercourse of some sort, which has got mineralisation in it. And so it creates this rather noisy area. These are not wreck sites, this is just geological noise. This site here is actually a wreck site with one small anchor on it. This site here is a 10,000 tonne steel ship that was wrecked in the 1880s. So you can see that if this site was somewhere in this area here, we wouldn't be able to find it, but in most cases it's in these very quiet areas. So we have possibilities of sometimes finding things with magnetics, sometimes not. But it's, from our perspective, it's a very efficient and interesting way which we hope in the future we may be able to improve the quality of how it's how we do it.
Thank you very much. May I ask John Logan? Podium, please. In the meantime, is there any question? We can have time for one Lars, please.
Hi, Lars from ITACA in Denmark. Do you have any ballpark numbers of the cost of these magnetic
Costing?
Yeah.
Well, I suppose in both, we've had 1, 2, 3, 4 magnetometer surveys done so far, and they've all been done pro bono, no cost. I do know that the cost for us of working for probably, we spent maybe 8 weeks searching and never finding anything. I think if we pay, if we pay for the